Hello, good day, doctor. We are from Group 4, Section 7. So, this is my group members me, Santeshwaran Sivaraja, Vedesh Ganapati, Shazwan Hadi bin Muhammad Suhaimi, Ravindran Balamurugan, and Muhammad Hafiz bin Muhammad Zairuddin.
Hello doctor, my name is Ravindran. For introduction, hydrology is the study of the water ability, movement and distribution. In Malaysia, the Department of the Irrigation and Drainage collects flood-related data using tools like public info engine. This study focuses on four main rainfall stations. It is the Ladang Lam Heng, Sungai Tiram kat Bukit Dagang, Ladang Lim Lim, dan and Sungai Sembilang at Kampung Sungai Sembilang, chosen for their high rainfall and its rate. Rainfall data is analyzed using arithmetic Division isotel method with Division polygon used for the comparison. Malaysia tropical climate brings high temperature, humidity and constant rainfall due to its equatorial location to influence from the intertropical coverage zone. Two major monsoons, it is southwest and northeast, cause the intense precipitation supporting river, groundwater and water supply. However, rapid urbanization and hilly drainage increase surface runoff and flood risk. To manage this, Malaysia used dams, drainage system, and washed management practice. These strategies are vital to harness rainfall beneath while minimize the environmental impact. Objective: collect rainfall and water level data from the Department of Irrigation and Drainage website. Second, analyze the rainfall data by being able to make mean aerial rainfall calculation using Bayesian polygon method. Third one, construct normal hydrograph and separate direct runoff and base flow using any method by and generate unit hydrograph. And last one, determine the peak flow and compare discharge value.
Hi, sir. My name is Vedish Unlucky Ganapati and my matrix number is DF240200. Now I'm going to explain the methodology part of our project. This hydrological study assesses rainfall, runoff, and also peak discharge in a selected catchment using data from June 2024 till May 2025. Rainfall data we took from four stations, which are Sungai Sembilang at Kampung Sungai Sembilang, Ladang Limlim, Sungai Tiram at Bukit Dagang, and also Ladang Nameng. Those four stations are inside our catchment area. For your information, these four stations were analyzed using the arithmetic mean method and decent polygon methods to estimate average. The rational method was also applied using data from Silica, which is the nearest point, factoring in catchment area, runoff coefficient, and also rainfall intensity. Finally, the reverse hydraulic capacity was compared to estimated peak flows to evaluate flood risk. The combined methods provided a comprehensive analysis of the catchment's hydrological behavior. Then the runoff was estimated using the unit hydrograph method by separating base flow from stream flow to determine direct runoff. Runoff depth was calculated at three cross sections with cross section 3 showing the highest peak. The result we got was more than 100,000 meter cube per second, which is the highest peak discharge due to its larger area and steeper slope based on Manning's equation. That's all from me. Signing off, Swedish Unlucky Ganapati.
Next is for data and analysis. Rainfall and water level station. Our group take four rainfall station. First, Ladang Nam Hang. Second, Sungai Tiram at Kampung Bukit Dagang. Third, Ladang Lim Lim. Fourth, Sungai Sembilang at Kampung Sembilang. And our group take one water level station, Sungai Tiram at Kampung Bukit Dagang. The rain profile upstream is mean hilly and steep terrain, narrow and fast river flow. Midstream, gentle slope, meandering river, and the last one, downstream, flat floodplain and high flood risk. Rainfall data collection. Our group data got from public info Banjir portal. Duration from January 2024 to May 2025. Total rainfall calculated using method arithmetic mean method and Bayesian polygon method. Mean aerial rainfall, arithmetic mean method. Total rainfall, we got 683.5 millimeter. Dyson polygon method, we got total rainfall 605 millimeter. So for cross-sectional hydraulic analysis, we got three cross-sectional. First, cross-section 1, slope, we got 1.9%, hydraulic radius, we got 7.32 meter, peak flow Q, we got 88,497.74 meter cube per second. For cross-section 2, slope, we got 1.7%, hydraulic radius, we got 4.6 meter, peak flow Q 31,629 meter cubes per second. For cross section 3, slope we got 3.7%, hydraulic radius we got 7.2425 meter, and peak flow we got 105,046.7 meter cube per second. Unit hydrograph analysis, direct runoff as flow rate, total runoff volume. For example, at cross section 1, uh, 15,379.2 meter cube, and runoff depth we got 0.032 centimeter. Ratio Rational method for peak flow runoff coefficient, we got 0.8, runoff intensity 20.98 millimeter per hour, catchment area we got 4,300 hectare, and calculate peak flow Q we got 251 meter cube per second. For additional note, high rainfall contribute to increased flood risk, catchment topography, and slope influence runoff behavior. Multiply method used to validate runoff, rainfall, and peak flow result. Importance of reliable hydrological data for flood mitigation. So next, I'm going to show you about the study case that we do by our own. First one, we take the data from the Info Banji website, and after that, we go to the Google Earth Pro to measure the distance, and we calculate the slope. After that, we calculate the area for place that we make our own study case. And from InfoBanjay we got hydrograph and hydrograph. After we got two graph that we calculate by using the formula that we learned from the class.
Okay, my name is Muhammad Fizli Mazaruddin. I'm going to present about the discussion part. Okay, based on the discussion part, which are the flood analysis in nature, based on our three rainfall station, which are Sungai Sembeling, Ladang Menanghel, Ladang Limling, and Sungai Tiram. We do the analyze part since from the January and July. We choose to decide to pick the March, which are from 13 until 21, which are 7 days. Then the full study period spent 3 months from data specific, which are 7 days. We have to study the rainfall pattern at the Johor, which we choose the Kota Tinggi district. Okay, based on data we found on the Department of Irrigation and Drainage, which are public info Banji, we realized that estimate mean aerial rainfall, which is essential for engineering, design, and hydrological study, which are the two methods we apply, which is the arithmetic mean method. We obtain 683.5 mm, and lastly the Dyson polygon method. We collected data which are 911.05 mm. From this data, we can do a calculation to determine the representative rainfall data for the study area, which are Kota Tinggi. As we all know that this is one of the affected area in the Johor due to the flood. Then By this data, we are supporting the future flood management infrastructure planning to avoid from the total loss of the properties and also people life. So from here, this data is totally full, important, especially to the hydrological part, which means we can detect from the level to level based on this data.
Hello, good day doctor. So now I'm going to present about the conclusion. For this project focus on analyzing rainfall and runoff behavior in 4 catchment areas in Kota Tinggi, Johor using real data from the Public Info Banjir portal and terrain profile from Google Earth Pro. Rainfall was analyzed using the arithmetic mean and Thiessen polygon methods, with the Thiessen providing a more accurate spatial estimation. Peak flow was estimated using both the rational method and Manning's equation, highlighting the difference based on the terrain and channel characteristics. Hydrograph analysis helped separate base flow from direct runoff, giving a clear view of stream response. Terrain profiling showed that upstream areas with the steep slopes caused faster runoff, while flatter downstream regions like Sungai Tiram face higher flood risk. Overall, the project successfully met its objective and emphasized the importance of accurate data, method selection, topographic analysis in effective flood management, and real-world hydrologic engineering. So thank you. That's all from our group.